Hi everyone, I hope you're all doing well. Today we're going to be talking about exception handling. Errors in programming languages, not just in Python, come in three flavors. There are syntax errors, and they are what happens when you have some kind of grammatically incorrect statement in the programming language that you're working in. And when these happen, nothing in your program will execute at all. Your program never gets running in the first place. That's because they can be detected right away. It can be detected or determined right away that there's something wrong with the code that you've written, something that breaks one of the rules of the programming language you're working in. Then there are runtime errors, and when we have runtime errors, your program will execute statements in your program until it encounters the problem. For example, you try to divide a value by 0 and then it crashes. You've also seen runtime errors when you try to print out, say, the value of a variable and you've never assigned any value to that variable prior to that point in the program. So Python doesn't know what should be in that variable and it crashes when that happens. And then the third type of errors, these are logic errors, and your program won't crash, but it just doesn't do what you want it to do. The program, there's nothing syntactically wrong with your code. I mean, it obeys all the rules of the language, and there's no kind of error in the code that causes the program to crash itself, but somehow you've just misunderstood the implementation of the logic that you're trying to do, and as a result, your program doesn't produce the results that you want. And they can be the hardest to deal with because there's nothing obvious to draw your attention to the fact that you've made a mistake, other than the fact that the expected behavior doesn't occur. And sometimes that can be quite subtle. Today's focus is going to be on runtime errors and how to handle them. Okay? And we're not going to be dealing with how to handle all runtime errors, but a certain class of them anyways. So what happens when we expect an int from the user, but they don't give us one? So we are asking, for instance, for a number from the user that we're going to use mathematically, and they don't give us one. Well, we get an error, right? It looks something like this. You can see in this code that I'm asking the user for an integer. I have an input statement here, and I'm storing whatever they type on the keyboard in this variable user int. So there's the prompt appearing on the screen, give me an int. And the user typed in Billy in this case. So they typed in the string Billy, which is not an integer. And then we are calling the int function right here and passing it the user int variable, what we hope is going to be a user int anyways. And we're calling the int function, and the job of the int function is to look inside that variable and give us return an integer version of whatever is in there, if it's possible to do so. And then we're storing it back inside user int, so because we want to essentially convert user int to an integer from a string. Remember, everything that we get via input is a string until we convert it into some other form if we need to do so. And what happens is we get a value error down here. Python is telling us that we have an invalid literal for the int function. The literal is the string Billy, B-I-L-L-Y. And of course, that can't be converted to an int. And as a result, we get a value error. And our program crashes and stops executing. So this type of error is called an exception or runtime error. Your program begins to execute since there are no syntax errors, but something goes wrong in the execution and the program crashes. In this example, we tried to convert the string Billy into an int. So Python's got a mechanism that's going to help us work around exceptions. We take our problematic code, the code that might cause an exception to occur, and we wrap it in a try except statement. Here's an example of that happening. You'll see that there's a function here called isInt, and it's expecting some kind of an input string. Here's the try statement, and in the try statement, we're taking input string and we're trying to convert it to an int. We happen to be assigning it to a variable I, but we don't have to do that. That's not necessary. If it's not possible to convert input string into an integer, for instance, it's something like the string Billy, then the except clause will be triggered, and we will take the action that the except clause specifies. So if a value error occurs, the exception will be triggered, and we will return false from this function. So this function will exit and send a value of false back. On the other hand, if we successfully convert the input string into an integer, then we will not trigger the except clause, and we will continue with the else clause. And the else clause says, hey, let's return true in that circumstance. So notice the comment here. If we execute the else clause, we know that the value in input string must be an integer. On the other hand, if the except clause is triggered, then that value was not an integer because the except clause gets triggered whenever this attempt to convert to an integer fails. So down in main, we have a variable called sumVar. You or I don't know what's in it at the moment. Okay, your code doesn't know what's in it. And we are passing it to the isInt function. Okay, if whatever's in sumVar is capable of being converted to an integer, then the function will return true, and this part of the if statement will be executed. On the other hand, if what's in sumVar can't be converted to an integer, then it will return false, and we will execute this part of the code. So you should put the stuff that can cause the exception to occur after the try in the try except. And you can have multiple statements in the try clause if you want. But you should, as a matter of good practice, limit statements in the try part of the try except, specifically to those things or to that stuff which could cause the exception to occur. Because if the exception is triggered, you want to know specifically what statements caused it to occur. And if you have a bunch of statements in the try clause, then you can't really know which one it was that caused the problem. All the other code that you want to execute when the exception does not occur, well, that should go in the else clause of the try except. You'll notice that the keyword value error appears in our code after the except. It appeared in the error, and you'll notice that the keyword value error, which was after the except in our code, that was in the error message that we got when we first ran the code. So I'm just going to pop back a couple of slides here and just show you that. It's right here. There it is, it's value error. So when a runtime error occurs, Python will tell you what the type of error is that occurred. Pop ahead again, sorry. Oh, sorry, it's here. So notice that the keyword value error, that appeared in the error message when we first ran the code. And in this case, value error is the name of the particular type of exception that occurred. We've seen name errors, for instance. So we know that there's more than one kind of exception that can occur. You do not have to specify the type of error that your except is designed to handle, but a try except can have more than one except clause, and you can take different action depending upon what type of exception occurs. So you could have except for value error, do such and such a thing, except for name error, do such and such a different thing. But if you don't know the type of exception, or if that's just kind of muddying the issue or muddying the waters for you, then you can just leave it out for now and it'll work fine. Try excepts can have an else clause, and that's what gets executed when the exception does not occur. So from now on, whenever you write code that can generate an exception, I want you to handle it with a try except. Okay, so here's the exercise that goes along with this lesson. You should write a program that requests a numerical value from the user. Then it's going to call a function or functions to determine if the user's value is an int, a float, or neither of those two things. So you can have more than one function if you want. The program should output whether the value is an int, a float, or neither. And the program should then, if possible, or convert the user's number to the appropriate type. So if they do give you a valid int or float, the program should convert it to the appropriate type. The main program should loop until the user inputs a valid int or a float. So you should be in a loop, the user should be in a loop until they give you a valid int or a float. And as a hint, check the comments in the try except code that's in the function in the sample code in slide 8. So that's it for this lesson. Thanks for your attention, and I hope you have some success. As always, email me if you have any issues, any questions, and I will do my best to get back to you as soon as possible. Thanks very much.